In this section, we're going to talk about simplifying complex fractions. So that means we've got fractions inside of our fractions. So, for example, I might have something like 1 over x minus 1 over y over 1 over x plus 1 over y. That's an example where I have fractions inside the fractions, and we can simplify this so it doesn't look quite so messy. There's a couple ways we can do it. We can just follow orders of operations, and because this is a division, there's implicit parentheses around the top and the bottom over the bar that divides the fraction. And then we can do the subtraction on top, the addition on bottom, and then we can flip and multiply. So let's do it that way first. So I find a common denominator on top, which is going to be xy, and I get y over x minus y over xy minus x over xy. And then we do the same thing on the bottom, and I get y over xy plus x over xy. And we end up with y minus x over xy divided by y plus x over xy. And then I can flip and multiply and get y minus x over xy times xy over x plus y. And the xy's will cancel. I'll be left with y minus x over x plus y. And that's a simpler form of that complex fraction. Okay, so we can just follow orders of operations, but that's the long way to do it. In my opinion, there's a faster way and an easier way to do this, but we have to think a little bit about what's going on. So let's see how this works again. So I've got 1 minus x over 1 over x minus 1 over y, and I've got 1 over x plus 1 over y. Okay, I look at all of the fractions in this, and I look at all of their denominators. The common denominator for all the inside fractions is xy, right? And so we're going to multiply the top and the bottom of the big fraction by the common denominator. So I'm going to multiply, let's get a different color. I'm going to multiply the top by xy and the bottom by xy. And what that's going to do, it's going to clear out the denominators of all of the fractions, and then I won't have fractions inside of a fraction anymore. I'll just have a single fraction because I've cleared out all the denominators. So let's see how that works. Okay, so this xy, it gets distributed to both pieces, right? And this xy gets distributed to both pieces here. So this is going to go in here and in here. This is going to go in here and in here. And we're going to get xy over x minus xy over y over xy over x plus xy over y. And now we can cancel inside, right? So I can cancel these x's, I can cancel these y's, I can cancel these x's, and I can cancel these y's. And what's left over is y minus x on top, because I've canceled, divided by this big division line. And then on the bottom, the x is canceled, so I have a y, and I've got a plus, and the y is canceled, so I have an x. Okay, so we just cleared out the denominators, and it reduced immediately. I think that's the faster way to do these things. Let's see another one using that technique. Let's look at something like, say, 4p minus 4 over p divided by 12 minus 4 over p. Okay, there's not 4 fractions in this, but there are fractions inside the fraction. If I look at all of the denominators, I have a p is the only thing in the denominator. So my common denominator for all the denominators inside the fraction is p. So I'm going to multiply the top by p, and I'm going to multiply the bottom by p. What happens then is, remember, this has to distribute all across the top, and this distributes all across the bottom. So you get 4p squared minus, well, the 4 and the p, when this goes inside, it's going to cancel with that denominator. I'm just going to have a minus 4 there. And then on the denominator, I have a 12 and a p, and I've got a minus, and again, these guys, I'm going to multiply by p, but I'm going to divide by p, so they're going to cancel. I'm just going to be left with a minus 4. Okay. This simplifies a little bit because I've got 4's everywhere, so I can factor out a 4 from the top. So I get 4p squared minus 1, and I have 4 times 3p minus 1. The 4's are going to cancel. I get to reduce this to p squared minus 1 over 3p minus 1. This is fine. We could factor it a little further. Factored form is usually the nicer form, so I recognize that as a difference of squares. I get p squared minus 1 is equal to p minus 1 times p plus 1 divided by 3p minus 1. And either of those two things would be a valid solution. Let's do one more really quick that's a little more complicated. So let's look at something like 2 over t minus 2 minus 1 over t squared plus t minus 6, all divided by 4 over t plus 3. Okay, finding a common denominator here is a little bit harder because not everything's in factored form. These first two, they have a linear term, a line in the denominator, so they're already fully factored. But this quadratic here, we can factor that. So let's factor that so that we can find our common denominators easier. And that factors as what, t plus 3 times t minus 2. That turns out nice that those were two of the denominators that I already had. Okay, and 4 t plus 3. Okay, so now my common denominator is going to be t minus 2, t plus 3, right? Okay, so I'm going to multiply top and bottom by that. So let me just write this all out again. T minus 2 minus 1 over t minus 2 t plus 3 divided by 4 over t plus 3. We're going to multiply the top and the bottom, put parentheses on the top, put parentheses on the bottom, by t minus 2 t plus 3. Okay, and then I've got to divide by the same thing because I'm multiplying top and bottom. Okay, so if I distribute this stuff to here and to here, we're going to have some cancellation. Same, this only has to go to one spot, but we're going to have some cancellation. Okay, what cancels here? On the top, I've got a t minus 2 on the bottom, but I have a t minus 2 on the top, so it's going to, those two things in the first term are going to cancel, and I will be left with a 2 times t plus 3. In the second term, I've got a minus sign, and everything cancels, right? So it's just going to be a minus a 1, and that's what happens to the top. In the bottom, the t plus 3's cancel. This is on the top of the bottom fraction, right? And the t minus 2 stays, so I'll have a 4 times t minus 2. And now I can just do a little bit of arithmetic. I get 2t plus 6 minus 1 over 4t minus 8. I get 2t plus 5 divided by 4t minus 8. And there's an odd term here, so I don't have any numerical cancellation going on. That would be my reduced form for that. That's pretty much it for this simplifying complex fractions. We'll talk next time about actual long division of fractions and algebra. Okay.